Our research and development in self-learning artificial intelligence at CogitAI is inspired in large part by complex tasks that intelligent animals can accomplish, but that has so far never been demonstrated by software systems. Take for example this video, produced by the BBC, in which remarkably, a crow is able to plan a series of 8 steps leading to a morsel of food in step 8. The crow shown here has already learned each of the steps individually, but is now learning to sequence them. The first thing it has to do is pull up on a rope to grab a short stick. The stick is too short to get the food, instead using the stick as a tool to get a rock out of another contraption. It has to do this 3 times. It then deposits the 3 stones into a device to release a longer stick, which it can use as a tool to release the reward. It's a feat of intelligence that we wouldn't have expected from animals, but does demonstrate an advanced capability that to date, software systems are unable to do. Our technologies and our self-learning AI platform are designed to teach software systems skills using a variety of methods. These range from autonomous self-learning to teaching skills by demonstration and providing feedback, enabling the software systems to fine-tune learned behaviors, and coaching, where a person observes the software system's behaviors and indicates when it is doing the right or wrong thing. Here is an example of how our self-learning technologies help software systems learn the skills and behaviors needed to accomplish a full task autonomously, just like the crow did. After approaching each ball using the skill learned through practice, it sequences skills for picking up the ball, driving to the basket, and dropping the ball in the basket. Note that at various stages throughout the task, it not only needs to be able to accomplish a skill, but it also needs to have knowledge of which tasks it previously accomplished. For example, once the yellow ball is in the basket, it needs to know to move to the blue ball, rather than searching for the yellow ball as it would have done prior to depositing the yellow ball. After completing that sequence 3 times, the yellow block is revealed, and the robot can use the skill it learned to put the block on the pressure pad in order to open the door. It will then complete the sequence by navigating out the door. In addition to simulation, our technology works equally well in the real world. Here you see our custom-built robot learning the skill of moving the yellow block to the pink pad. Inset in the top left, you see a mobile phone screen that shows the view from the robot's camera, as well as an interface that allows a person to indicate to the robot which sub-skills it should use in various situations, thus teaching a behavior. Though autonomous practice, as shown in the previous segment, is effective, it can take a fair amount of time. We have therefore also incorporated technology into our platform that enables a person to teach the robot by demonstration or other forms of feedback, as shown here. The robot learns considerably faster. You just watched a sped-up version of the entire training sequence. However, it does take human effort. Here you see the learned skill after training. We have also developed algorithms to enable the robot to fine-tune such behaviors that have been learned from a demonstration by subsequently practicing autonomously. This is just the start of how we can train software systems to continually self-learn. We are also working on enabling software systems to transfer skills among one another and expanding the capabilities towards more complex sequences, thus expanding the real software system's capabilities that can be implemented in many real-world use cases. Learn more about CogitAI at cogitai.com.